of the final project for the Managing Machine Learning project course offered by Duke, which I'm doing as part of the AI product management specialization. The ask of the project is to come up with a problem within my industry that might have a potential machine learning solution and to describe how I might set up the machine learning project, identifying the process, design decisions, and potential issues one might face. The project will be evaluated on the basis of the following criteria: clear problem statement with potential opportunity evaluation, business analysis of the current situation, steps for solution validation, considerations in machine learning system level architectural decision, and articulation of potential production risks. In terms of the opportunity context, let me first state that I'm not a medical underwriter or an insurance agent. This project is based on my knowledge of it as an epidemiologist and experience in working in the healthcare industry for the past 12 years. I'll be making certain assumptions about the health insurance industry, some of which might not be fully validated. So let's begin. Medical underwriting is the evaluation of risk for the purposes of accepting or rejecting an insurance application for medical or life insurance. Today, it's largely done manually by expert underwriters who use rules engine to pass through a set volume of data related to the application and other supportive data to get a risk score for a specific customer who's applied to the insurance. This method is manual and therefore prone to human error. This method is also retrospective. That is, there's no flag to identify future risks. If the predictions are incorrect, then the patient turns out to be of higher risk than what was identified or predicted. They may encounter a major illness, which means the insurance company has to pay out for this care. This can make certain categories of people undesirable, patients undesirable for insurance companies, therefore the moratorium on pre-existing conditions and such. This creates an adversarial relationship between the insurers and the consumers. This is also bad for patients specifically because if the prediction were looking forward or forward-looking, then they could have been informed of a potentially preventable disease. The solution here is to use machine learning algorithms to do forward risk prediction. In trying to understand whether this is a problem that machine learning can solve, we evaluate whether this is a problem in the first place. Can machine learning be useful, and is this valuable to anybody? First, yes, this is a problem because in the current system of underwriting, both the customers and the insurance companies lose out. Machine learning can help solve this problem because machine learning is good at using large amounts of data to make accurate predictions, which is exactly this scenario. And yes, someone cares. Insurance companies want to make underwriting efficient and want to increase prediction accuracy, so they care. And potential customers care because if risks are prospectively flagged to customers, they can avoid, prevent, or prepare for illnesses. Here are some details to clarify our business understanding. Our target users are insurance underwriters. The current problem is that underwriting is laborious, time-consuming, and prone to human error. This matters because insurance companies lose out and patients lose out as well because of lengthy underwriting processes and inaccurate predictions. Today, it is solved by human experts using rules engine. So if you don't have access to expert underwriters with years of experience, you're out of luck. And even if you might have expert underwriters, if certain populations or groups of patients do not exactly fit the criteria within this rules engine, you can get inaccurate risk prediction. So if you were to implement the solution, what would success look like? Well, we expect that underwriters would be 50% more efficient than they are today if we implement the solution. Our current constraints are that those expert underwriters with years of experience might be worried about implementing AI solutions where the perception could be AI is taking over my job. But encouraging a culture change where their mindset would shift from that AI is taking my job to the mindset would be AI could be used to augment my job. That mindset shift might be difficult, and therefore it's a question of change management. And then in terms of the second constraint, medical underwriting can be very complex. Therefore, for some complex cases, machine learning alone can't give the right prediction. It needs to be a system that has human in the loop. Our outcome metrics are related to underwriting efficiency. Underwriter will be able to process 10 cases per hour instead of 5. So effectively, they're doubling their efficiency after we implement the solution. And they will have their error rate. Our output metric is the percentage of accurate predictions and the mean squared error of aggregate predictions. This project will be considered a success if we're able to consistently have more than 90% prediction accuracy with the lowest mean squared error for a specific model. So what are the factors that might impact our prediction? There are a lot of factors. An applicant's social demographic status, for example, their age, gender, ethnicity, education, income level, what neighborhood they live in, all of these can impact their health risk. Obviously, their disease history will have a material impact. Whether they choose to lead a healthy lifestyle or not will also have an impact on whether their risk increases or decreases over time. Epidemiologic factors such as incidence or prevalence of disease or risk factors will also have an impact. And finally, an applicant's social determinants of health, which is their employment status, access to health services, housing situation, etc., will also have really big impact on their health risk. The expertise we will need to assess in this project will be medical underwriters, epidemiology scientists, and insurance analysts. The proposed solution here is to use machine learning algorithms to provide medical risk prediction for customers using multimodal data obtained from various sources. These sources of data could be the form that the applicant uses when they apply for insurance, but also their electronic medical record, their wearable data, data from their social network, etc., and combining that with national and international databases for epidemiology of diseases and such that was described earlier. We'll take an iterative approach to implement the solution. During the modeling process, we'll use cross-validation to identify the best model performance. We'll then trial the solution in a relatively small population and compare the results with fully human expert underwriting. And then we will slowly expand the scope of solution implementation as we improve model performance. In terms of cloud versus edge, we'll use cloud-based systems because we don't need very low latency. Underwriters will have internet access when they're making these analyses, and will be using data stored in the cloud from various sources following standard privacy and security measures, so this isn't a massive concern. In terms of offline versus online learning, we will choose online learning because we'll retrain our model weekly or monthly as new data comes in. And because this risk calculation is something insurance companies do every quarter or every year, this isn't something that needs to have online learning. In terms of batch versus online predictions, we'll do batch predictions for each customer every hour and cast these predictions and show them to the underwriter in batches. So what are some potential risks in production? We should not have any training serving skew because the training data and input data for production are both real-world data. We should not have any latency issues as well. There is a mild potential for data drift because populations keep changing. Demographic shifts due to migration or Brexit or pandemic, etc., will change population characteristics, so there is a risk that the prediction might degrade over time. There's also potential for concept drift because if people increasingly become more and more healthy and health conscious, adopting healthier lifestyle, the algorithm might be overestimating a customer's risk, resulting in higher rate of rejection. And finally, this is an area with significant potential for bias. We need to carefully and regularly check for systemic bias to ensure we're not excluding any specific groups of people, for example, those from ethnic minorities, those with disabilities, or those from underserved and unrepresented communities. And we must take immediate steps to correct these biases in the model. This is the end of my presentation for the course project. Thank you very much.